I know you've missed me, kids. This is Mrs. Lehman from Math with Mrs. Lehman. I'm here with my sixth period class. Today we we have just finished our Module 1 test, and we are starting Module 2. So look at that lovely clip art. It's gorgeous. All right. So the kids now have their module booklets. Oops. And we are going to start Lesson 9. Yes, we're not starting with Lesson 1. New York State kind of does things in its own interesting way, we'll say. So we decided to rearrange some stuff in Module 2. So we're starting with Lesson 9, Sums and Differences of Decimals. And you guys should already know what sum means. All right, on the count of 3, everyone tell me what operation sum means. So I want you to say either add, subtract, multiply, or divide. Ready? 1, 2, 3. Add. Oh, yeah, they're good. All right, differences. 1, 2, 3. Subtract. Okay, very good. So we're talking about decimals, though, so there's a rule that we have to remember. When you're adding or subtracting decimals, we need to make sure we do what? Blaze.
We need to line up the decimal point.
Very good. All right, so everybody in your notebooks right now, please write that down. Line up decimal points. All right? You guys did this kind of when you were in elementary school, except for you didn't know the decimal point was even there, right? You just did it without even realizing it. You added ones up with ones and tens up with tens, and now, because we're older, we're aware of more things, and we know that there are decimal points at the ends of numbers. All right, so we just have to line those up. Well, what we're doing in today's lesson is we are looking at denominators that are kind of magical. They are a power of 10, all right? So on our assessment, we had the question, and you kids in class are not writing this down because it's a mistake. Don't write it down. All right. This was one of the questions. You had to convert 5/8 into a decimal, and some of you guys said this. And I started to cry a little bit. You know, I got shaky and weak, and I said, oh, they didn't listen to a word I said. All right, what does this line here mean between the 5 and the 8? What operation does that signal?
To divide.
To divide, yeah. So guess what, kids? When you divide, it doesn't magically work out to 5,800. So what we're working on today, though, is if you have some compatible denominators, we can turn it into something where we can essentially just write down the numbers. So let's say, for example, we have 3/4. All right. Now, we want to make that so it is a power of 10. So we can write it as tenths or hundredths or thousands, etc. Okay? So we want it to have a denominator that's a power of 10. Now, this works with certain denominators. It'll work with 2, obviously, right? It'll work with 5. 10 is already where it needs to be. It would work with 4. It would work with 25. It would work with 20. It would work with 50. All right, so what denominator over here could we use? Brianna's. Yep, the denominator is the bottom.
100.
100. Who agrees with Brianna? All right, generally, I wouldn't necessarily say you should agree with Brianna, but in this case, yes. I'm just picking on her. All right, so 4 times what gives us 100? Aubrey? Times 25, very good. And 3 times 25 is 75, very good. So 75 hundredths. Now, that's how you say it as a fraction. As a decimal, what does that look like? And we're going to say it kind of the way that's not so technical. How would that look as a decimal?
0.75.
Yep, 0.75. So, again, this place right here is the tenths. This under the 5 is the hundredths. All right? Not under the 5. Where the 5 is the hundredths. All right? So, if you can scale up the fraction or scale it down to make sure that denominator, that bottom number, is a 1 and zeros after it, so a power of 10, then you're golden, all right? Otherwise, you're going to have to rely on the old method of turning a fraction into a decimal, which is what? To divide, yep. All right, so here we go. There's not too many math wizard tricks in these examples. They're pretty straightforward. All right, so the first one says 25 and 3/10. How would I write 3/10 as a decimal, Jacob?
25.3.
Very good. 25.3 is, again, the first spot past a decimal point is our tenths place. And then this one we're going to line up again. So here would be the decimal point. And then 77 hundredths, how would I write that? Jonathan, how would I write 77 hundredths?
Zero 0.77.
Yep, very good. Except for we have 367 whole whatever, so that's going to be, instead of a 0, we're going to write that, and then 77. Now, what can I put after that 3 that will not change the value of a thing, Christoph?
0.
0, very good. So we're just changing the forms of these numbers without changing their value. All right, so now we're adding. 0 plus 7, everybody. 7. 3 plus 7. 10. Put your decimal point down. Carry your 1. So we have 1 plus 5, which is 6. 6 plus 6 is 12. Carry your 1. 1 plus 2 is 3. Plus 7 is 10. Carry your 1. 1 plus 3 is 4. 4. There's your answer for that one. Okay. Any questions on that? No. All right. Let's go to example 2. All right. So we are going to start like this. 246 and 1/5 minus 275 and 1/2. All right. I know how much everybody loves working with fractions, right? You love it? All right. So because we're just learning to convert these numbers into decimal equivalents, we are going to write these as decimals right now. So 426, that whole number is not going to change. All right. Now, I can't write 0.15 because that's making up my own math rules. All right. I need to make that, I'm going to erase that decimal point. I'm going to make that out of 10. All right. How do I get from 5 to 10? To get from 5 to 10, Cam?
Times 2.
Times 2, very good. So 10 times 2, so 1 times 2 is 2. All right, have I changed the values of these numbers? No, not at all. I just changed how I wrote it. All right, so this next one is 275, and that's not a 10. 2 times what gives you 10? Everybody? 5. So 1 times 5 is 5. All right, now, it seems like a lot of work, but it's really nothing. It should take you a long time. All right, 426. How do I write 2/10? Cassie?
426.2.
Very good. 0.2. And 275 point, what would it be for 5/10, Michael?
5.
Very good, 0.5. All right, it's all lined up. We're going to subtract in this example. So 2 minus 5, if you tell me 3, I will be very upset. All right, 2 minus 5, everybody. Can we do it? No. No, we got to go next door. And I'm going to move this. And Sue's going to say, hey, 6, can I borrow 10? Sure. Here you go. All right. So 12 minus 5 is, everybody? 7. Bring down your decimal point. All right. The next one. 5 minus 5. 0. 2 minus 7, can't do it. Hey, 4, buddy. I'm borrowing from you. 12 minus 7 is 5. And 3 minus 2 is 1. There you go. There's your second answer. Any questions on that? All right, let's go on to another example. All right, exercises 1 and 2. Calculate each sum or difference. So Samantha and her friends are going on a road trip that is 245 and 7/50 miles long. So it's telling us the total amount of miles that they need to travel. They have already driven 128 and 53 hundredths. All right, how much further do they have to drive? So again, it says Samantha and her friends are going on a road trip that is 245 and 7/50 miles long. They have already driven 128 and 53 hundredths. How much farther do they have to drive? So if we're given a total amount and we know what's already been done and we're trying to figure out what is left to do, what operation would that be? Would we want to find the sum or find the difference? Would we add or subtract? What do you think, Joey Rapp? Joey Rapper? You dropped your rapper. Alright, so yes, we are going to subtract. So we're going to start with 245 and 5. I can't. What I'm saying and what I'm writing are two different things some days, apparently. That's what's happening today. It is Monday after all. Alright, so I'm going to start with the original form that they are giving me this info in. And now I'm going to make sure that I have a power of 10 as a denominator. So I have a 1 and zeros after it. Alright, so this first one, the whole number isn't going to change. I'm going to change this to 100, right? So to get from 50 to 100, I multiply by what, Stephanie? 2. 7 times 2 is 14. So we know that's 14 hundredths. Right? We have 128 and 53 hundredths, so we don't have to mess with that at all. And we are subtracting. Now, we are going to convert these fractions to decimals. So 245 and 1400. So that's going to be point what? 0.14, right? That 4 is in the hundredth spot, so we're good. So 128.53. We are subtracting. Here we go. 4 minus 3, everybody. 1. I can't take 5 from 1, so I've got to go next door. 4, 10. 11 minus 5 is 6. Put your decimal point. 4 minus 8, can't do it. Knock, knock. Me. All right, here's 10. Go away. 14 minus 8 is 6. 3 minus 2? 1. 2 minus 1? 1. That's hard math, because you had to subtract 2 minus 1. All right, so 116 and 61 hundredths. Very good. What do I label this? Miles, yep. So you should write that in a pretty sentence that says, Samantha and her friends still have 116 and 61 hundredths of a mile to go. But, due to time's sake, we are moving on. All right, any questions thus far? Okay, did you get that wrapper off the ground? Yeah, okay, thanks. Sorry, just a small interruption. I get distracted by wrappers on the ground. Okay, the next question is talking about Ben, and he needs to replace 2 sides of his fence. We're not going to ask what happened to Ben's fence, but it was probably just some weather. All right, one side is 367 and 9 hundredths meters long, and the other is 329 and 3/10 of a meter long. How much fence does Ben need to buy? So, key things we need to underline. First of all, Ben needs to replace 2 sides of his fence. One side is 369 and 9/10 meters long. That seems important to me. How about you guys? Yeah, let's underline that. The other is 329 and 3/10 meters long. Underline it? Yeah. All right, and we need to figure out how much fence he needs to buy if he's replacing each of those pieces. So, you're going to either say sum or difference. On the count of 3, are we finding the sum or difference? Ready? 1, 2, 3. I heard some. Let's try that again. Ready? 1, 2, 3. Sum is correct. All right, so 367 and 9 hundredths plus, finding the sum is adding, 329 and 3/10. All right, that's all beautiful, except for we want to work in decimals. All right, now this one's pretty easy because what do we notice about the the denominator of both of these numbers? What's going on there? What do we notice about that? What do we notice? Brianna?
Look at
Okay,
me.
both are a power of
10.
10. Very good. So it's a 1 and zeros after it. So 367 point. Now, how do I write 900ths? How do I write 900ths? Don't get trapped by the math wizards. Michael.
0, 9.
All right, but we don't need a 0 there, right? Because it's...
Yeah, no.
Oh, wait. What do you mean 09? 0.09? 0.9.
0.09.
Very good. 0.09. I got messed up. All day I've heard kids say 0.9. I go, no. All right. So I was thinking you were saying 0.9. It's like, well, first of all, we have 367 whole, whatever, right? Meters. And 900ths. I'm kind of rambling. All right, so 329. Welcome to math class with Mrs. Lehman. All right, 3/10. How would I write 3/10? I've heard from a lot of kids, but some I haven't heard from much. Messiah, who's on fire? All right, go ahead, Malaya.
0.03.
0.03. It's only 3/10, so that would be
So
300ths.
So 0.3.
0.3, yep. So this first place past the decimal spot is the tenths place. So if you only have tenths, that's where your number ends, right? If there's 2 digits there, and it's hundreds, it should go, 2 over. Okay. Anyway, there's not anything here underneath the 9. What can I put there without changing any value of that? Mr. Aiden.
0.
0. Yeah, as long as you're not changing the value of anything, you can add zeros on the end of that. All right, 9 plus 0 is 9. This is tough. You expect me to do this in 6th grade? What? 0 plus 3? Decimal point, don't forget it. 7 plus 9? 16. Carry your 1. That's 7, 8, 9. 3 plus 3 is 6. I'm going to have to wrap this video up because that's the end of math with Mrs. Lehman for today. Everyone say goodbye. Bye. Until next time, kids, I'll hope you'll like and subscribe all of my cringy videos. All right.